In this video, we're going to talk about limiting and excess reactants. Now, up until this point, we have always assumed a reactant is completely used up in the reaction. But that's not always the case. So today you're going to find out that, in fact, there's usually a reactant that's left over in the reaction, and that's called the excess reactant, and it's always present in greater amount. So when the reaction is over, you're going to find that there's some left over in the beaker once the reaction is done. Now, in the example of the moles of iron and copper lab, your excess reactant was the iron nail because you still had some of it left over in the beaker at the end of the day. Now, the limiting reactant or reagent is present in a small amount or limited amounts and will be completely used up in the chemical reaction. So none of it will be left over when the reaction is completed. Now, it's the limiting reagent or reactant that will determine the maximum amount of product that is possible. So now moving forward, we're going to, if we're given two pieces of information in a calculation, we're going to have to figure out which is the limiting reactant and which is the excess reactant. Okay. In previous questions, you didn't have to worry about that. You were always given one piece of one piece of information. So you had like the moles of iron, and that's it. And then you had to figure out everything else. Now, moving forward, you may be given two pieces of information, meaning you'll be given both masses for the starting materials, and then you have to figure out which one is going to produce the smallest amount of product. So that's what we're going to practice today. How do you find the limiting reactant? The first thing you're going to do is predict the amount of products formed using stoichiometry calculations. Then the reactant, which produces the least amount of product, is going to be called the limiting reactant because that will give you the actual amount of product formed. Now, the reactant, which produces the most product, is going to be called the excess reactant, and we don't want to use that information moving forward. Okay, so we're only going to use the limiting reactant for all further calculations and values. So let's practice this. If you have 20 moles of H2 and 40 moles of F2, which reactant is in excess and which is the limiting? So let's go ahead and set up our equation here. Okay. We can just leave it if we don't know the phase 100%. So we have 20 moles of H2, so I'm going to write that down. And we have 40 moles of F2. Now remember, in this question, you're given two pieces of information to start with, and we're trying to find the excess. So maybe I can say here, how many moles of HF will form? Okay, so this is what we're trying to find. So what we're trying to do is we're trying to connect this small bridge, and then we're also trying to connect this small bridge. So we have two mole bridges we're trying to connect. So that means we have to set up two separate calculations here. So let's set up the first one. So we want to figure out the moles of HF, but we're going to start with a 20. Moles of H2. We're already in moles, so we can go right into the mole bridge there. And then we also want to find the moles of HF based on the 40.0 moles of F2. So I'm going to do this in parallel here so you can see what's happening. So the first mole bridge is going to be a 1:2 ratio, 2 moles of HF for every 1 mole of hydrogen gas needed. And then here we have 2 moles of HF for every 1 mole of F2 needed. And then we work this out. And we're going to find that the moles of H2 should cancel out and the moles of F2 should cancel out. So we should be left with 20 times 2, so that's just going to be 40.0 moles of HF based on H2. And then here we're going to get 80.0 moles of HF based on F2. Now F2 produced more product, so that's going to be our limiting our excess reactant, and hydrogen produce the lesser amount of product, so hydrogen will be the limiting reactant. So H2 is the limiting reactant, or LR, and therefore 40 moles HF are produced. That's the amount that you can form, okay? And then the 80 moles of HF based on the F2 numbers would be the false information because we cannot produce that because we don't have enough. H2 for that reaction to work out. Okay, so you can say here F2 is the excess reactant. Okay, you can also carry out a very simple calculation just to confirm that F2 is in fact in excess by saying, okay, how many moles of H2 are really needed if we started with 40 moles of F2? And if you go ahead and say for every 1 mole of F2, you need 1 mole of H2, and you work this out and you find that in order to react all of the F2, you're going to need 40 moles of H2 will be needed. But if you look at your starting point, you only have 20 moles. So that's why F2 is the excess reactant. It needs 40 moles of H2 for this reaction to work out. So you know that that's never going to work out. Whereas H2, because it's a 1-to-1, only needs 20 moles of F2 to react with to form 40 moles of HF. So that's why H2 is the limiting. It limits the amount of product formed because there's not enough of it, and F2 is the excess. It needs too much of the starting materials and it forms too much product. Okay, let's go ahead and try a few more examples. So once again, pause the video at this point, try the example, and then continue the video. So here we have 15 grams of H2 reacting with 40 grams of Cl2, and we want to see how many moles of HCl will form. So go ahead and set this one up, and I'm just going to set up my 2 mole bridges, just show you what I'm trying to calculate here. And so I'm just going to walk you through this one here, and you can pause it at any time, obviously. So because I have 2 starting materials, I have to set up 2 stoichiometry calculations, one for H2 and one for Cl. And then the one that gives me the smaller amount of product, the least amount of product, that's going to be my true value that I will use for answering my final question. Oh, I'm not at mole bridge yet, so I can't draw those, so I have to continue on here. So for every 1 mole of H2, I have 2.0 grams of H2 from the periodic table. And for every 1 mole of Cl2, I have 71.0 grams of Cl2, so just following along here. So now I'm at the point where I can now cross the mole bridge. I'm going to jump ahead there. And it's a 1:2 ratio. So for every 2 moles of HCl forming, I need 1 mole of H2. And for every 2 moles of HCl forming, I need 1 mole of this diatomic, which is Cl2. And working through this, I am left with what I need at the final, as my final set of units here. And, oh, bring that back. So my first answer is going to be 15.0 moles of HCl, and that is based on hydrogen. And then for the next one, I'm going to be left with 1.13 moles of HCl, and that's based on Cl2. Now, because Cl2 gave me the smaller amount of product, then I know that that is going to be my limiting reactant. So my limiting reactant for this one is going to be Cl2. And the excess is hydrogen. Cl2 is a limiting, so I can only form 1.13 moles. All right, let's try the next question here. Determine the amount of magnesium oxide that can form if you react 55 grams of magnesium with 30 liters of oxygen at STP. So I'm trying to connect this mole bridge, and then I'm also trying to connect this mole bridge. So the reason why I have two mole bridges is because I have two starting pieces of information. In the previous questions, you might have only had 55, or you might have only had the 30 liters and had the 1 mole bridge. So that's why here we have to figure out which one is going to give us the true answer, the limiting product. That's why we have these two bridges we set up. And we want to find the amount. Why don't we say the amount in, we can say it in grams this time. So we'll say we want the grams. So we'll just go like this, grams of MgO. And then we want the grams of MgO again, but this time we'll base it on 30 liters of oxygen, and this will be 55 grams of Mg. So go ahead and work this out. And I'm just going to set up mine. You're going to find the moles. We're left with moles here. Once we multiply or divide through, liters are gone. And now we're left with moles. So now we can go ahead into the mole bridge for both of them. It's a 2:2 ratio, so it's really going to reduce to 1:1, but I'll just put down the 2 and 2, just so you can see exactly where those numbers come from. And here, this one is going to be a 2 moles of Mg to 1 mole of oxygen. So just be a little careful there. So now we're left with moles. The question is saying go to grams, so we just need to do one more conversion here. So for 1 mole of MgO, we're going to need to figure out its molar mass. And the molar mass is going to be 40.3. When you work this out, you're going to be left with some numbers. So work it out, and let's see what you get. So I'll leave that for you guys to solve. Actually, hang on. I'm just trying to zoom out here. So the limiting reactant works out to magnesium, but I'm just going to show you the full calculation here. Divided by 24.3. So this one here is going to be 91.2. That's if we keep all the digits, 91.2.